there is a couple of things we need to talk about before we get into this lesson. And this is a couple of things that we need to talk about. Everybody write these two words down. Included angle. Included angle. We have to define that before we get started today. We also have to define something else. What is an included angle? Well, here we go. Let's draw a triangle to help us out here. And let's label that triangle A, B, and C. And let's put tick marks on two sides. What sides do y'all want to put tick marks on?
B, A.
BA. Okay, what else?
BC.
BC. All right, fantastic. In your best guess, where do you think the included angle would be? What angle would be included?
C.
It'd be C. Okay, anybody else? A. All right, anybody else? Well, there's only three choices, right? It's either A, B, or C. All right, let me give the definition for an included angle. An included angle is this. It is the angle that is located between the two sides.
So B.
Angle located between two sides. So in this case, we're talking about this side right here, and we're talking about this side right here. What angle is between this side and this side? B. That angle right there. That is the included angle. Okay? You can also do this without picture representation. Let me give you a for instance. Take side AB, take side BC, and tell me what angle is in between AB and BC.
B.
B is. Why is B in between AB and BC? Well, the picture's right there, coach. But this is without picture representation. You can tell what angle's between the two because what do they share? They share a B. So B would be the angle between those two sides. Okay? That's what included angle means. Okay? All right? Now let's talk about non-included angle. So if it included was an angle located between the two sides, where do you think a non-included angle is going to be?
A and C.
Yeah, it's going to be the angle not between two sides. So in this case, we're talking about A, B, and B, C. Here's the included angle. It's between the two sides. And now we have what? We have two angles that are non-included. So we have angle A is non-included. And we have angle C is non-included. Okay? You can also have included sides and non-included sides. Okay? Any questions? That's the background information that we need to know before we talk about today. So let's get started. I want you to write this one down first. Okay? SSS Theorem. SSS Theorem. Everybody write that down. Yeah, there's a lot of notes to take, I understand. But for 22 years, I've done it this way, so I ain't changing nothing. SSS. What do y'all think SSS stands for? Think about it. We're talking about triangles. What do triangles have? They have what? They have sides and they have angles, right? So what do you think SSS stands for?
3 sides.
3 sides. So we say side, side, side. And this is what the side theorem says. It says if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. Write that down. If three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. The world doesn't need to know that. What we're going to do for each of these is we're going to write them down, then I'm going to draw you a visual representation of each of these. Okay. A, B, and C. D, E, and F. In order to show, because in geometry, listen to me, you can't assume anything. If those were perfect drawings and they both looked the same, you could not come to the conclusion that they were equal to each other, because that's assumption, and you can't assume anything in geometry. So what we have to do is we have to prove things. In order to prove things, I might have to take a ruler and measure each side and show that those two things are congruent. Luckily for you, I do know this. That side and that side are the same. Okay? Because I'm the one drawing, right? That side and that side are the same. And this side and this side are the same. And if I have two triangles and all three sides are equal to each of the three sides on the other triangle, then I can say without a doubt that triangle ABC is congruent to triangle DEF. And it does make a difference how you write it. You cannot say triangle ABC is congruent to triangle FED. You can't say that. Because why? Because of what we already talked about last week. Y'all remember SSS? Y'all remember that? Y'all remember CPCTC? Corresponding parts of congruent triangles? Everything has to match, correct? So AB here has to match DE. Okay? And if I say FED, it doesn't match up. AC has to match what? DF. Okay? Everything has to match. So it does make a difference how you write it. Okay? All right. That's side theorem. That's probably the easiest theorem there is. If three sides of one triangle are congruent to three sides of another, then the two triangles are equal to each other. Bing, bang, boom, done. Okay? All right, let's move on to the second one, which is in the middle there. And it is the SAS theorem. SAS theorem. And what do you think SAS stands for? Do what? SAS?
Oh, yes,
Side, angle, side. Very good. Side,
No.
angle,
Angle, side,
No. That's all.
We got that right.
side.
Angle.
Side, angle, side. Okay? Now, you pay attention to these words. If two sides in the included angle of one triangle are congruent to the two sides and the included angle of a second triangle, then the triangles are congruent. Where's that angle got to be located? Where's that angle gotta be located? It's gotta be located where? In between the two sides. Okay, it has to be included, okay? So again, word representation, write that down. Then I'm gonna give you a visual representation. And we're gonna do it with triangle ABC and triangle XYZ. So I have to show two sides in the included angle of one triangle is equal to two sides in the included angle of a second triangle. So here we go. I'm going to show you that AB and XY are congruent to each other. Okay? I'm going to show you that AC and XZ are congruent to each other. What angles now have to be congruent in order for SAS to happen? What angle in this triangle? It's the included angle. So what angle's between the two sides here? Say it. What angle's between the two sides here?
E.
Hey, this is between the two sides.
Oh, okay.
Okay, you see that? What angle has to be here? X has to be. So I got side, angle, side, and I got side, angle, side. So therefore, these two triangles are congruent to one another by side, angle, side. So I can say that triangle ABC is congruent to triangle what? A matches to what? X. B matches to Y. Z. Does it make a difference how it's written?
Oh, yeah.
Yes, it does. Good Lord. Okay, moving over here. I tricked you. We have the ASA theorem. What do you think ASA stands for?
Angle side, angle.
Bam! Angle, side, angle. Angle, side, angle. Where do you think that side's located? Where's it, what is it between? In the words, where's it between? The two angles, right? So where do you think this side is located?
In between.
In between, thank you. So it says this, if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. Write that down. We'll talk of visual representation. Oh, God, I'm gonna slow down.
Slow down.
Don't be laughing at me.
That's rude.
That is rude. D, E, F. Brandon, you taking notes?
No.
You'll help the line. But if I called your mom and we get it taken care of.
You're not supposed to be video.
Yes, I am. The world's gonna see.
It's the world for me.
All right, we're talking about the side between two angles. Keep that in mind. Here we go. I'm going to say this, that B, you want me to really mess you up? No, I'm not gonna do that. And E are congruent to each other. Okay? I'm going to say that A and D are congruent to each other. Okay? You better pay attention here. You ready? this side and this side are congruent to one another.
What side?
Are those two triangles congruent?
Yes. No.
Oh,
I got a yes and I got a no and I got a no and a no.
Wait, point to it again, what side?
Is okay, you got this angle, this angle, this side.
Okay.
You got this angle, this angle, this side. Are the two triangles congruent to one another? No, they are not. Because why? You also have to explain why. Just saying no doesn't make it right. Why are they not? Because, coach, that DF is not the included side. It has to be an included side, coach. So what side in this triangle has to be match that one? Between D and what? E, which would be side what? DE. So I have two angles in the included side. I have two angles in the included side. Okay? Now I can say that those two triangles are congruent to one another. Okay? All right, moving on. Last one today. I didn't say I was through talking today. Last one today. AAS.
Angle, side.
AAS, angle, side. Very good. Man, we got that down. Angle, side. Please be quiet. Angle, side. Now pay attention to these words. It says if two angles and a non-included side. So is that side going to be between the two angles now? No, it is not. Okay? If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the triangles are congruent. Write that down. Here comes visual representation. I'm going to use D, E, F. I'm going to use L, M, O. I got tired of ABC. And they don't even look congruent to each other. Okay. If two angles in it, let's do the two angles first. Here we go. This angle is congruent to this angle, and this angle is congruent to this angle. Okay? Now it says if two angles and a non-included side. So first off, where is the included side? The included side in this triangle. It's the side between the two angles, right? Which it would be what? DF. Okay, it's between the two angles. Okay, LO is the included. So it's got to be one of the other sides. So, two angles and a non-included side. So I'm going to mark that one, because that is not between the two angles. And I'm going to mark this one right there. Are those two triangles congruent to each other? No, they are not. Because it is not the same side. Okay, so what must I do? Mark that side right there. Okay, so I have two angles and a non-included side in one triangle. I have two angles and a non-included side in a second triangle. Therefore, those two triangles are congruent by AAS. Okay?